Hello students, welcome to Legacy IAS Academy. So today we are going to discuss a very important concept of geography, that is plate tectonics theory. So if we talk about the plate tectonics theory, this is considered as most widely accepted theory and also most recent theory as far as the surface movement of the earth is concerned. We can trace back the history of this theory to somewhere in 1960s and early 1970s when we have three geographers, one Harry Hess, other we have is J.T. Wilson, and third what we can say we have is Arthur Holmes. So basically if we talk about the plate tectonics theory, the contribution, major contribution in this theory has been made by Harry Hess, J.T. Wilson and Arthur Holmes. Apart from that, sometimes Morgan is also associated with this particular theory. So first, before understanding what the plate tectonic theory stands for, what does it describe or what are the major elements of this theory, we have to understand about the term plate. What does basically the term plate means? So if you look at the structure of the earth, what we can see that overall we can divide the earth into three parts, three layers basically. The upper layer is what we call as crust, the central layer is what we call as mantle, and the innermost layer is what we refer as core. Now initially, before the plate tectonic theory was given, it was believed that it is the crust layer that is moving over the mantle layer and the mantle layer is moving over the core layer. However, as more and more what we can say scientific technology is developed, then people started to understand, scientists basically they started to understand that it is not the crust that is moving over the mantle, rather than it is the crust, and then attached to the lower end of crust we have a small upper region of mantle. So the crust is entirely solid and the upper part of mantle is also solid in nature. So basically the crust and upper solid mantle, this layer is behaving like a single layer. That means what changed? Before, when the scientists were saying the crust is moving over the mantle, now scientists started to say that it is not only the crust but the entire crust along with the upper solid part of mantle is moving over the lower layers of mantle. Now the entire single layer consisting of this crust and upper solid mantle was given the name of lithosphere. So that is the first term. What is lithosphere? Lithosphere is nothing but entire solid crust and upper solid part of mantle which behaves like a single layer. Now later on, when more inspection was made, when more research was conducted, it was found out that this entire slab of lithosphere is moving over the part of mantle which is weak in nature. Weak means in terms of its strength, it is a weak layer. It is a kind of what we can call as a semi-solid layer. Semi-solid in the sense is that whenever pressure is applied over this semi-solid layer, this layer start to behave like a fluid. So basically this semi-solid layer was given the name of asthenosphere. So we have two layers. One, the upper layer what we refer as lithosphere and the lower layer is what we refer as asthenosphere. So basically what is happening, the lithosphere is moving over the weak layer, the semi-solid layer which we refer as asthenosphere. Now the first point that can come into mind is what is the thickness of this lithosphere. So thickness of lithosphere is not fixed at every places, it varies from place to place. But overall we can understand that it goes all the way up to 100 to 130 kilometers from the surface. Now the question comes, then what is the plate? So basically if you look at the lithosphere of the earth, the entire earth is not a single solid layer, rather it is broken into multiple parts, multiple fragments. Thus plate is nothing but individual broken fragment of lithosphere or individual broken part of lithosphere. That is how we can define or explain about the plate. So if you look at the entire surface of earth, overall on the basis of size, plates can be classified into major plates, minor plates and micro plates. But overall what we have to understand the plate tectonics is the movement of major plates relative to each other. Thus, the entire surface of Earth is divided into 7 major plates. These 7 major plates are, you have some plates that are continental plates and some plates that are the oceanic plate. So, overall in two of the overall plate, you have two oceanic plate, for example, the Pacific plate and the Australian plate. These are considered as a oceanic plate. On the other hand, we have 5 continental plates, such as we have Eurasian plate, for example, we have African plate, we have Antarctic plate. So, Eurasian plate, African plate, Antarctic plate, then we have North American plate, we have the South American plate. So, these 5 plates are what we can call as the continental plate, and thus what is happening basically in plate tectonics, there is a movement that is happening of all these plates with respect to each other, and this is what we call as a plate interaction that is responsible for all various types of geophysical phenomena that we observe on the surface of Earth, be it volcanism, be it earthquake, be it what we can say is the formation of the fold mountains, be it the formation of Rift Valley like a structure and all these. So, we are going to discuss in the later part of this video. So, overall what we have understood till now, that the individual broken part of lithosphere which is moving over the weaker region of asthenosphere is what we can call as plate, and plate tectonics stand for the evolution, that how the plates are forming, the movement and the interaction between each of these individual plates. So, as we have just described, plates can be divided into two types, oceanic plate and continental plates. Thus, coming to the second topic is plate interaction, that how the plates are moving and how the plates are interacting. Now, the reason why plates move is given by Arthur Holmes in another theory that was given before plate tectonic theory, that is simply referred as convection current theory. So, the convection current theory is what we can say is a building block of the plate tectonics theory, because this theory explains the forces responsible for the movement of the plates. Now, how this theory explains the movement of the plates? So, it is very simple. Suppose that we have one plate like this here, and this plate is moving over the layer of asthenosphere, that is mantle. Now, this plate can be both either oceanic plate or the continental plate. So, what Arthur Holmes said, that what is happening here, we have the core region and this is our mantle. So, near the core mantle boundary, we know the temperature is very higher. Around this region, temperature is more than 3000 degrees Celsius. On the other hand, near the crust mantle boundary, this boundary near asthenosphere, temperature is in the range of around 800 to 1000 degrees Celsius. So, due to this, what happens? Due to this temperature differences, we have the movement of the molten rocks in the upward direction, which is referred by Arthur Holmes as convection current, and that is why the theory is called as convection current. So, what is convection current? Basically, it explains that we have the movement of the hot molten magma from near the mantle core boundary toward the crust mantle boundary in a huge volume, in a huge plume like shape we can say. And as this convection current rises up, it applies force on this plate in the upward direction. Due to this, what happens? This plate basically break apart into two individual plates, and as this plate break apart into individual plate, we have the emergence of magma above the plate, that also is what we can say is responsible for volcanic eruption. And at the same time, now what happens, as this magma reaches here, now this magma, all of the magma cannot move above the earth's surface. So, some of the magma start to flow below this plate in the opposite direction. So, as the plate start to move in the opposite direction, as the convection current start to flow in the opposite direction, it drives the plate also in the two opposite directions. And then gradually what happens, the horizontal flow of convection current is happening, that is moving the plate in different direction according to their movement. Now, as this convection current spend more and more time near the surface, near what you can say crust mantle boundary, the temperature of this convection current or temperature of the magma that is making up the convection current start to decrease. And as the temperature of this magma start decrease, obviously what will happen? The magma will become cooler, and if the magma is becoming cooler, that means it will become dense, and as it becomes denser, the magma start to sink back toward the mantle. and again as it reaches toward the mantle core boundary, again it heats up, rises here. Same thing happens on this side as well. So basically what is happening, below the earth's plate, below the lithosphere of the earth, we have several such kind of convection current that is continuously moving, continuously flowing, and that is what is responsible for the movement of plates in different direction. Even the breaking of the plates, the splitting of the plate is also attributed to the upward pressure and force exerted by magma. So that is what convection current theory of Arthur Holmes tries to explain, that what is responsible for the movement of lithosphere and the individual part of lithosphere that we call as plate. So till now we have discussed what is plate, how does plate moves, why does plate moves. Now coming to the third and most important point about plate tectonics is about the plate interactions. So if we talk about the plate interaction, we have discussed, we have total two types of plate. Thus overall the plate interaction can be classified into three categories or three types. One, what we call as convergence. Second is what we can call as divergence. And third is what we can call as transform plate interaction. So we have convergence, we have divergence, and we have transform plate interactions. So in simple term, how we can explain it? So convergence is a very basic English word. Convergence means when two different things are converging. Converging means when they are coming toward each other. So in the same context, what is convergence? Convergence is when two different plates, it can be either oceanic plate, it can be continental plate, but simply when two different plates are coming toward each other, and after once they start coming toward each other, sometime what will happen at some point in time, they will start to collide with each other. So such kind of plate interaction is what we call as convergence. And generally what is observed, that at the boundary where convergence between two different plates is happening, we have the destruction of the rocks. Thus the other term which is very important we have to remember is the convergence, the zone of convergence, the convergent plate boundary we can say is also referred as destructive plate boundary, because rocks of the plate are destroyed here. So convergence or destructive plate boundary where two plates are coming toward each other. Now if you look at the earth's surface, convergence can be of multiple type. So three types of convergences we generally see on the earth's surface. We have convergence between oceanic and oceanic plate. We have convergence between one oceanic plate and the other continental plate. And third type of convergence what we see is when there is a convergence of two continental plates with respect to each other. Thus convergence is of three types: OO convergence, OC convergence, and CC convergence. Similarly, when we come to the other type of plate interaction, this is referred as divergence. Now divergence is nothing but reverse of convergence. So divergence can be simply explained when we have two different plates. It can be continental plate, it can be oceanic plate, when they are moving away from each other from a common boundary. When two plates, whether it is oceanic or continental, when they move away from each other from a common boundary, then such kind of interaction is called as divergence. And generally wherever we have divergence at the boundary, we will see the development or formation of new rocks. Now how this happens we will discuss later, but since there is a formation of new rocks near the divergence zone, divergence plate boundary, such boundary is also called as constructive plate boundary. So the convergence is related to destructive plate boundary, divergence on the other hand is related to constructive plate boundary. Now if you look at the divergence, we have basically two types of divergences that we see on the earth's surface. The first divergence is what we can call as oceanic divergence, divergence between two plates, and second we have is continental divergence. So here we also have two types of divergence, O divergence and CC divergence. Then third and last type of plate interaction that we see is what we refer as transform plate interaction, which sometimes is also written as a transverse plate interaction. So both are same, transform plate interaction or transverse plate interaction. Now transverse plate interaction or transform plate interaction refers to such kind of plate movement where two plates are neither moving toward each other nor moving away from each other, rather they are simply sliding along a common boundary. So, for example, this is our plate 1, this is our plate 2. So, what is happening basically along this common boundary, the plates are simply sliding along each other, and thus what happens here, neither the new rock layer is being constructed nor the older rocks are being destroyed. So, basically what is happening, whatever rocks are present here, the rocks are conserved, and that is why the transform plate boundary is referred as conservative plate boundary. So, transform plate boundary we can refer as a conservative plate boundary. Why? Because neither the rock is being destroyed nor the new rock is being created. And as far as the transverse plate interaction, transform plate interaction is concerned, we see on the earth surface only one type of plate interaction, that is the continental transform plate interaction. Thus, if we have to talk about the plate interaction, we can basically divide it into 6 parts, 6 types: OO convergence, OC convergence, CC convergence, then we have OO divergence, CC divergence, and then we have the continental transverse plate interaction. So, these are the major types of plate interaction. Now, what we have to understand here in more detail is what are these plate interaction, what is the result of these plate interaction, how do these plate interaction happens, what are the geophysical phenomena associated with these plate interactions, and what are the major landforms that you can expect to form whenever such kind of plate interaction happen. So, let us look at each of these plate interactions one by one individually, starting from the convergence. So, first we have OO convergence. Now, OO convergence basically refers to such kind of plate interaction where two plate, that is oceanic plates, are converging or moving toward each other. So, let us try to understand this by drawing the diagram properly. So, suppose we have a oceanic plate, this we can call as O1, and then we have the other oceanic plate here which we can call as O2, and since obviously this is an oceanic plate, we can expect that above these oceanic plate will have the ocean water that will be resting above these plates. Now, interestingly, we have discussed at the beginning that why do these plates moves, because below each of the plates we have the convection current that is flowing here. Like this. So, this is our convection cell. The combination of convection current is what we can refer as convection cell. So, this is our convection cell 1, this is our convection cell 2. So, this is our oceanic plate 1, this is our oceanic plate 2. Now, what basically scientists had observed, that whenever two plates are converging toward each other, whenever two plates are colliding with each other, if the plates have difference in their density, then generally the denser plate start to subduct. That means it start to subduct below the lighter plate. So, for example, in this case we have assumed the O1 plate to be denser because it is subducting below the O2 plate. So, O2 plate is lighter plate, it has low density. O1 plate is denser plate because it has high density. Now, why O1 plate has high density? It is basically believed that if you comparing two oceanic plates, the oceanic plate which is more older, that has greater age, will be more denser because it will be more colder. Oceanic plates are forming due to the cooling of magma. So, if the oceanic plate is older, that means the cooling is happening to a greater extent. If cooling is happening to a greater extent, that means what we can say, density will be relatively higher. That means O1 plate is denser as well as have greater age, more older. O2 plate is lighter as well as younger. So, as the oceanic plate start to subduct below the other oceanic plate, what happens here? We have formation of a deep valley like structure here. At the place what we can refer as subduction zone, we have formation of a trench. Now, trench is nothing but a narrow and deep valleys that develop near the subduction zone. And as these plates start to subduct, gradually what happens? The temperature start to rise. And as the temperature start to rise, because O1 plate is going below in the mantle, temperature start to rise. So, the melting of the rocks of these O1 plate begins. Now, as the rock of this O1 plate start to melt, what happens? There are gases that is trapped in these rock structure. So, these gases are also released, and at the same time we have the magma that is being produced here due to the melting of the rock obviously. So these trapped gases and magma which is having low density, which are lighter, they start to rise in the upward direction, or we can say they start to move in the upward directions. Now as they start to move in the upward direction, what happens? These magma and gases start to break through the rocks of this O2 plate and finally reaches above the surface of this O2 plate. The hot and molten magma, when it reaches suddenly above the O2 plate, what happens? It comes in contact with the cold oceanic water. At the bottom of the ocean, temperature of the oceanic water is somewhere about 4 degrees Celsius. So you can understand magma which is 800 to 1000 degrees Celsius hot, it suddenly comes in contact with the cool water that is 4 degrees Celsius, and then we have sudden and rapid cooling of magma that happens on the ocean bottom. So what happens? The magma start to gradually become more and more colder, it start to solidify and then start to deposit itself on the oceanic floor. As more and more magma produces, because the O1 plate is continuously sinking, subducting below the O2 plate, continuously the new magma is being formed, and then this magma keep on reaching above the earth's surface. So gradually the height of these magma, solidified cool magma, will keep on rising, and finally a time will come when this magmatic structure, a kind of, we can say, mountain like a structure, sea mount, we can say sea mountain, so it rises above the surface of the ocean, and as it rises above the surface of the ocean, what happens? If suppose if you are flying over the oceanic area, what kind of structure you can, as you can see here, obviously it will resemble to you like an island, because this part of landmass is surrounded by water from all the side. Thus what we can say has formed here as a result of O convergence. What kind of what we can say geographical structure has developed here? So obviously the answer will be, here we have development of volcanic island. Now interestingly, it is not only a single island that will develop here, because this plate is not a two-dimensional plate. The entire plate is like this. So the entire plate is subducting below the other plate. That means everywhere you will have what? You will have volcanic eruption at multiple places, and thus you will see a kind of chain or arc of volcanic island that will develop here. So we have volcanic island arc, we can say, or volcanic island chain, which many times is also referred as archipelago. So as a result of this, we have development of archipelago, volcanic island archipelago. Whenever we have O convergence, the best example of this you can see in the case of islands that have developed in the Indonesia and Philippines. They have, these countries together have more than thousands of islands, and all of these islands are which kind of island? These all are volcanic island chain that has formed due to the O convergence, because around both these countries, on one side you have the Australian plate and on the other side you have the Pacific plate. So due to the convergence between the Australian oceanic plate and the Pacific oceanic plate, we have formation of chain of island around the edges, around the subduction zone, which is today part of Indonesia and Philippines. So that is the first thing. Now what kind of geophysical phenomena you can expect as a result of O convergence? So obviously one thing we have discussed, we will have volcanic eruption, obviously we will have volcanic eruption. Second point is that if volcanic eruption is happening, obviously it will cause disturbance in the rock structure. So due to this, what else we'll have? So we'll have volcanic eruption, yes, we'll have earthquake, obviously we will have earthquake because the rocks are being disturbed. And everything is happening where? It is happening somewhere in the ocean, deep ocean, middle of the ocean. So due to this, what happens? If the earthquake is of very high magnitude on the Richter scale, this earthquake can actually cause sudden displacement of large volume of water. And this sudden displacement of large volume of water can send a wave in a ripple-like fashion from the point of disturbance, and this ripple-like wave that radiates out from the point of disturbance and then reaches the coast, becomes very, very high in the height, is what we can call as the tsunami waves. So the other geophysical phenomena or natural disaster that can happen here due to result of O convergence is, obviously we can have formation of or development of tsunami waves, as we have seen in the case of India, when on 26th December 2004, due to earthquake that happened in the Bay of Bengal region, we have the gigantic tsunami wave that affected almost the entire Indian Ocean countries in the eastern part of the Indian Ocean. So that is about the O convergence. I hope up to here all points are clear to you. Now the second type of convergence what we have to talk about is OC convergence. That means when we are having convergence between oceanic plate on one hand and the continental plate on the other hand. So when we have OC convergence, what basically happens? One plate we can draw is the oceanic plate, and the other plate we will have is the continental plate. Now obviously since it is oceanic plate, we can understand that we will have the water that is resting above this plate going all the way up to continental side. This we can call as the high tide level. So what else we can see from this diagram? This is the oceanic plate, this is the continental plate. So oceanic plate is obviously much more thinner, while continental plate is obviously very thick. However, if you look at the density, oceanic plate is having high density, while the continental plate, despite it being so thick, it is having relatively low density. The reason is very simple. The continental plate is largely made up of granitic rock, which is having an average density of 2.0 to 2.2 gram per cubic centimeter. On the other hand, oceanic plate is made up of basaltic rock, which is having slightly higher density of 3.0 to 3.3 gram per cubic centimeter. So obviously when we are having the convergence between the oceanic plate and continental plate, what happens? The denser plate, as we have discussed before, will subduct below the lighter plate. So oceanic plate, because it is made up of basaltic rock, start to subduct below the continental plate. Now as this oceanic plate start to subduct below the continental plate, same process will be repeated as we have seen in the last example. So what will happen here? As this oceanic plate subduct inside the mantle, temperature will start to increase. As the temperature start to increase, the rocks and the gases trapped in these rock layers start to convert into magma, and as this convert into magma, it rises up. Now as it rises in the upward direction, what happens? It applies upward pressure or force on this continental crust or the rocks of the continental crust. It causes melting of the nearby rocks of the continental crust, and then these molten rocks of the continental crust also start to become part of the magma as magma rises through the continental crust. Thus what we can understand here, that this magma, the initial magma, is made up of basaltic rock because it is forming due to the melting of the oceanic crust. On the other hand, as the basaltic magma rises and breaks through the continental crust, it also melts the nearby rock of the continental crust, and thus the granitic rock of the continental crust, continental plate, start to become part of this magma. And when finally this magma break through the continental crust, continental plate, we can say, it reaches above the surface of the plate, and due to this what happens? It start to cool down, start to solidify, and then start to form a mountain like structure due to continuous accumulation of magma in this zone. And this mountain like structure have rocks of so what will happen? Because what is happening here, we have basaltic rock, and this is what we have is the granitic rock. So yes, that is correct, that what will happen, as these rocks finally reaches above the surface of the continental plate, we have mixture of basaltic and granitic rock, and these rocks are generally what we call as andesitic rock, and the name is, you have Andes mountain in the South America. So that is from here you have Andes, andesitic. So gradually what happens, the height of this mountain start to increase, and in the same way we will have volcanic eruption at the entire stretch of the oceanic plate, and thus you will have a chain of volcanic mountain, or what we can say as volcanic mountain chain, that will develop here across the entire edge of the continental plate, in those places where the subduction is continuously happening. So what we can say, what kind of geographical features are forming here due to oceanic convergence? We are having volcanic mountain chain formation, and What kind of geophysical phenomena we can expect here? Obviously, we'll have volcanic eruption. Obviously, we can have the earthquake. So, two major geophysical phenomena you can expect to take place at the zone of OC convergence. The best example of this, if you look at that, where in the world we can see such OC convergence to take place, such OC convergence that can happen, that happens. So, the best example is around North America and South America. So, what is happening on the upper side? We have North America. So, this is North American continental plate. This is our South American continental plate, and this side we have the oceanic plate that we call as the Pacific plate. So, what is happening? Pacific plate is subducting below both the North American continental plate and the South American continental plate, and as a result of this, all along the edges of this continental plate you will find a mountain structure. On this side we have, for example, Alaska range, one of the major mountain range. Then you come to the south, you have the Rocky mountain ranges there. You go further to the south, and further in this side, if you can also add one mountain range, that is Cascade mountain ranges there. You go further to the south around California, you have the Sierra Nevada is there, and then in the South America you have a single range of mountain that is referred as Andes mountain range. So, all these mountains forming on the western coast of North American and South American continent is a direct result of the OC convergence, where the Pacific oceanic plate is converging below the North American and South American continental plate. So, this is how, if you are suppose writing examination, writing mains examination. So, rather than just writing the example that where do we have OC convergence and all these names of the mountain, it is suitable to draw simple diagram, just outline diagram is required here, outline map of the North America and South America you can make, and then show all these mountain ranges like Alaska range, Cascade range, Sierra Nevada range, Rocky ranges and Andes mountain ranges. That will be more than enough and will fetch you good marks as well. So, that is about the second type of plate interaction. The third type of plate interaction is what we can call as CC convergence, and we have convergence between two continental plate. So, in CC convergence what is happening? Same thing, we have two continental plates, a thick continental plate are there, they are colliding with each other. Now, what happens basically here, because both plates are continental plate, this we can call as C1, this we can call as C2. But the problem is that almost all the continental plates have formed in the same time period. That means, and all the continental plates are made up of similar kind of rock. That means there is not much difference in the density of these continental plates. Hence, if there is not much difference in the density of the continental plate, what will happen? If the convergence is happening, none of the plates will be able to subduct below one another. And that is why what happens, due to the forces of the convection current, they start to collide with each other, they start to apply pressure and force on each other near the zone of collision, or we can say as that is also referred as collision zone. And due to this continuous forces, what we can say is the compressive forces, the sediments that are present near the marginal areas of the continental plate as well as the rocks of the marginal area of the continental plate start to rise here. This rise of the sediments on rock at the point of collision or near the zone of collision is referred by the term of upfolding. So, basically what is happening, the CC convergence is leading to upfolding, and this is the upfolding that results into formation of a mountain like structure that you can see from here, which is called as a fold mountain. So, we have the formation of fold mountain, the best example of which is obviously our Himalayas. So, Himalayas are the example of fold mountain that has formed due to similar kind of convergence, that is continental convergence. So, CC convergence leading to formation of fold mountain. Now, obviously what kind of geophysical phenomena you can expect to take place here? Will we have volcanic eruption? If we talk about the volcanic eruption, for example, so answer is obviously no. Why? Because for volcanic eruption to occur, what is required? We require the formation of magma, and since none of the plate is subducting below each other here, what happens? None of the plate is able to go down far below the mantle so that it can form or convert into magma. So since there is no magma formation, generally you will not see the volcanic eruption occurring near the places of CC convergence. What about earthquake? The answer is yes, definitely. If you look at the world map, the most earthquake prone areas, most earthquake prone zones are basically those zones where we are having the continental convergence. For example, Himalaya itself, if you talk about India, Himalayas are most earthquake prone zone, most earthquake sensitive region of India. So obviously earthquake can happen. Can tsunami happen? That again is not possible, because if talk about the CC convergence, it is happening where? It is happening somewhere in the middle part of the continent. That means it is far away from any kind of water bodies such as oceans. So if there is no water bodies, no ocean nearby, no matter how significant is your earthquake, it will not cause disturbance in the oceanic water. And if there is no disturbance, what we can say, the probability of tsunami will also be less. So only one phenomena that will occur here, geophysical phenomena that will occur here, is the earthquake, and the physical feature that you will see developing here is obviously your fold mountain. So this is what we can understand is the result of continental convergence. Apart from Himalayas, what are the other examples? Obviously we have Alps mountain is another example of the fold mountain. Himalayas are example of the fold mountain. So why Himalayas are forming? Because we are having CC convergence between the Indian plate that is still moving at the rate of 4.5 centimeter per year toward Eurasian plate, and the Alps in Europe, they have formed due to the CC convergence between the African plate, which is continuously moving toward the Eurasian plate. And similarly, if you talk about the Arabian plate, a small minor plate is there. So Arabian plate also is moving toward the Eurasian plate, and that is why you have the formation of Zagros mountain. So Alps, Himalaya. If you want to know the other example, we have Zagros mountain. Zagros mountain is there in the Turkey and nearby Iran region. So these mountains also have formed due to the CC convergence. So these are the best example of the mountains that has formed, fold mountains basically, that is formed due to upfolding, that is result of the continental convergence. So that is all three types of convergences that we have to discuss here. Now coming to the next type of plate interaction, which is a divergence. So in divergence, simply what is happening? We have, for example, if we talk about divergence, the first divergence what we have to talk about is the oceanic divergence. So what basically happens is that if suppose we have a oceanic plate and then we have the magma that is coming from below, the convection current that is rising from below. So first what this convection current will do, it will split one single oceanic plate into two plates, as you can see here. So this we can see is the O1 plate, this we can consider it as a O2 plate. Now as the plates are broken apart due to the flow of horizontal convection current, as we have discussed before, they start to move in the opposite direction. So one convection current is moving horizontally in right, one convection current is moving horizontally to the left. So in that case, what will happen? A kind of gap is created here, and through this gap we have the upward rise of magma that again comes in contact with the cold oceanic water and thus solidify, accumulates on both sides of the oceanic plate. Now new rock layer is forming here, and at the same time this O1 plate is being displaced on this side, O2 plate is displaced slightly on the other side. So gradually what will happen, new rock layer will keep on forming and they'll keep moving away from this area where you are having the upward movement of the convection current. This region, because this area, if you try to understand, it is a kind of area, a broken area, a gap area. On both sides of this gap you have the mound like shape because of the accumulation of magma. So this is what we can refer as mid-oceanic ridges, or in short it is also referred as MOR, which is one of the most dominant feature of the oceanic region, right? So we have okay, in the last we will discuss about what other books you can refer to, okay, once we end the session. In the end of the session we will talk about book list. Then what we have is the mid-oceanic ridge, right? So MOR is on the most dominant feature. So where you can expect to see the MOR? Obviously, you will see somewhere in the central part of the ocean, because that is the place where the oceanic plates are basically drifting away from each other, diverging away from each other. And thus we have the formation of mid-oceanic ridges. The longest mid-oceanic ridge actually you can find it is in the S kind of shape. If you look at the middle part or the central part of the Atlantic Ocean, we have the S-shaped ridge, which is the longest mid-oceanic ridge of the earth. So now what kind of feature we will find here? So obviously we will have this mid-oceanic ridge that you will see here. What kind of geophysical phenomena you can expect here? So obviously we will have volcanic eruption, we will have earthquake, and since it is happening in the middle of the ocean, what you can expect? You can expect actually tsunami to occur. However, the probability of occurrence of tsunami is relatively lesser here. Why it is so? Simple reason is there, because the velocity or the pressure with which magma erupts here is not very high. Simply what is happening, the plates are getting displaced away, and as the plates are displacing away, what is happening? They are basically giving way to magma. Thus magma does not erupt violently, does not erupt with high pressure, high force, and due to this gentle eruption of magma, the disturbance in the oceanic water is relatively less. So theoretically, obviously you can expect to tsunami to develop here. The probability of formation of tsunami development to tsunami is very less because of the gentle eruption of magma. So that is about the mid-oceanic ridges that is forming at the divergence zone of two oceanic plate. The best example, as we have discussed, is S-shaped mid-oceanic ridge in the Atlantic Ocean, which is referred as mid-Atlantic ridge, and interestingly, if you look at the upper part of mid-Atlantic ridge, you have a country that is situated here. This country is what we can call as Iceland, and that is why if you go to the Iceland, you will see that Iceland is basically being broken apart. A single landmass is there, single country is there, that is being broken apart because one part of plate is moving in the left direction, one part of plate is moving in the right direction, and thus a large valley like a structure, a rift valley like a structure you will see developing in the Iceland. So that is about the oceanic divergence. The second type of divergence what we have to talk about is CC divergence. Now CC divergence is very important because this is the most recent divergence that is happening, and that is why this divergence is also referred as neotectonics. Neo refer to new and tectonic is the plate tectonics. So the CC divergence that we see today around in the African region is what we call as neotectonic movement. So basically what is happening here, actually if you draw the map of Africa, CC divergence, what is the CC divergence? We have discussed clearly that when the continental plates are moving in the two opposite directions from away from each other from a common zone. So basically on this side of the Africa, if you draw from here, you will find a rift valley like a structure. One rift valley that is coming from the west and one rift valley that is coming from the east. So this is what we can call as East African Rift Valley, or what is referred as East African Rift Valley, and this side we call it as a West African Rift Valley. Now why we have formation of Rift Valley in this region? Simple, because this part of Africa, which is many times is also referred as a Somali plate, because Somalia is situated here. So there is a small part of the major African plate that is referred as Somali plate, and then we have the northern part, this is referred as Nubian plate. So what basically is happening, Nubian plate is moving in other direction and Somali plate is moving in the eastward direction. So due to this, what is happening, as the CC divergence happens, the land is being pulled apart, the crust, the continental crust of Africa in this case is being pulled apart, and that is why in the first stage what we are seeing, we are seeing the formation of a valley like structure. So the East African, West African Rift Valley is largely a result of continental divergence. Now let us first understand that how this divergences can proceed. So in the first stage, what do we have? Suppose we have a undisturbed continental plate. Now as divergences begins, what happens? Convection current is flowing in the opposite direction. It will start to break this crust into two parts, and as the crust is broken apart in two parts, what will happen? We can expect, if we draw a three-dimensional diagram to understand more better, the central part where the crust is being broken apart, you will see a formation of this kind of valley like structure. That means after some time, if you come to this area, you will see that one part of plate will be here, and this is the region around which the convectional current basically are moving in opposite direction. So we have formation of a valley like structure in the central region of the single continental plate. So this is what we can refer as first stage, development of a rift valley like structure. Now obviously what will happen, as the convection current keeps moving away from each other, they will be pulling the continental plate into opposite direction. That means what will happen now, the rift valley that has developed here in the first stage, there will be widening of the rift valley, and as the rift valley become wider and wider, we talk about as this rift valley become wider and wider, a time will come when this valley can open up itself toward the ocean or sea. And thus in the second stage, what will happen here, in the second stage of CC divergence, the valley will become very wide, and as this valley become very wide, what will happen, the water from the nearby ocean will start to enter into this rift valley area, and thus the entire widened valley will get flooded by the oceanic water, and thus in the second stage you will have formation of what we can call as sea-like structure. So in first stage, CC divergence is creating a rift valley. In second stage, CC divergence is creating a sea-like structure, and that is why if you look at this map again, here we have the formation of rift valley because it is in the first stage of divergence. And if you go slightly to the north, what you are seeing here, this entire region, this is also a sea. What is this sea called? This side we have the Arabia, and this side we have Africa. So what is this, a small narrow sea between Africa and Arabia? The answer is, this is the Red Sea. So Red Sea is actually, how Red Sea had formed? It has formed due to the continental divergence that has happened in the past between the Arabian plate and the African plate. Before it was a rift valley. As the Arabian plate got displaced more in the northward direction, the rift valley became wide enough, and the water from the nearby Indian Ocean started to enter into this rift valley region, causing accumulation of water, forming the sea-like structure. So Red Sea. Now what will happen if the process keeps on going for a longer period of time? The sea will keep becoming wider and wider, becoming bigger and bigger, and the continental crust that was earlier present here, it will be replaced by a oceanic crust, because the magma will keep on rising up and will forming a new layer of crust. Thus we are having the destruction of the continental crust, we are having the formation of the new oceanic crust, and at the same time we are having the, what we can say, widening of the sea into what we can call as the ocean. That means in the last stage, of continental divergence, if we try to understand what will happen, the sea that has formed in the second stage, it will become so wide, the bottom of this continental crust will be replaced by the oceanic crust, and then this continental part will be somewhere here. On the other side we will also have this continental part, and in between this area we will have widening of the sea that has formed here, and once sea become wide enough, it can then be called as a ocean. So in the last stage we have formation of the ocean that is lying between the two initial continental crust, C1 and C2, or plate we can say C1 and C2, and the best example of this is obviously Atlantic Ocean, because if you go back to a theory that is called as continental drift theory given by Alfred Wegener, there he has described that what is happening, initially we have a Pangea, that is a supercontinent. Pangea is making up both North America, Europe, South America, Africa, and thus as the splitting happened, what actually happened, the North American continental plate started to move in this side, and this side we have the Eurasian continental plate, and the region between the North American and Eurasian continental plate, what happened, it converted into sea first, the sea become wider, and this wide sea converted into the Atlantic Ocean. Thus on one side you have the North American continental plate, on the other side you have the Eurasian continental plate. So that is about the second type of convergence, that is continental convergence. The last type of plate interaction then we have to discuss is the transform plate interaction. Now transform plate interaction, as we have discussed before, it refers to a movement of two plates when the plates are neither moving toward each other nor moving away from each other, but are moving along a common boundary with different velocities in different directions. Maybe even if they are moving in same direction but at different velocity, we can call this as a transform plate interaction, because in any way there will be some sort of relative motion along the common edges. So the best example of this you can see in the United States of America, USA. The country itself is a part of North American plate. However, in this larger North American plate, you have the, what we can say, a smaller plate. This plate, which we can call a small plate, is there, minor plate is there, which is referred as California plate. So this is our California plate, and this is the part of the main North American plate. So North American plate is moving in the southern direction, while the California plate is moving in the northern direction. And as a result of this relative motion along this common boundary, what is happening? The plates are rubbing against each other, they are sliding past along each other, and thus we have the formation of a fault zone, because obviously what will happen due to this? The rocks will break. So the place where rocks break, this place is what we call as fault zone. And the most important fault zone that you can see here is what we call as San Andreas fault, which is a very, very important place along the California. So this is California plate, North American plate, and this is the example of transform plate interaction. Obviously, will volcanic eruption happen here? The answer is obviously no, because there is no development or formation of magma. Will earthquake happen here? The answer is obviously yes, because earthquake happens whenever we have disturbance in the rocks, and if there is a movement between plates, no matter which kind of movement happening, convergence, divergence or transform plate movement, there always will be a relative motion. That relative motion will disturb the rock. This disturbance will create seismic waves, and the seismic waves will generate earthquake. So yes, obviously earthquake will happen here. And if you look closely around this area, what do we have? This entire region is basically covered with water, because this is Pacific Ocean. So if high magnitude of earthquake happens, we can also expect that tsunamis can occur in this region as well. Thus, in this case, the transform plate interaction can cause two major natural disasters, two major geophysical phenomena, earthquakes and tsunami. Now recently, one other place was in news due to the earthquake, a very disastrous earthquake that has happened in recent history of the entire world, we can say, is we have Turkey. So basically, if you look at Turkey, this is, we have Turkey on this side. So Turkey also on this side, if we say this side we have the Black Sea and this side we have the Mediterranean Sea. If you look at the plate, so this side of Turkey we have the African plate and this side we have the Arabian plate. So, and upper side we can also understand we have the Eurasian plate. So the location of Turkey is such that it is lying between three plates: Eurasian plate in the north, Arabian plate in the east and African plate in the south. And all these three plates are moving with respect to each other. Thus, the Turkey, which is called as Anatolian plate, there we see a relative motion that is happening, because what basically happens here, if you talk about this is your Arabian plate. So Arabian plate is moving in the northward direction toward the Eurasian plate, and also what is happening, Eurasian plate is also having relative motion like this. So basically, due to the movement of Eurasian plate and Arabian plate, it is kind of causing the westward movement of the Turkey plate. Turkey plate actually is called as Anatolian plate. Thus, two fault lines we can see in the Turkey, one to the north, one to the south. The northern fault line is what we call as North Anatolian fault. Anatolia actually was the old name of Turkey. So North Anatolian fault, and here we can find is what we can call as South Anatolian fault. So we have North Anatolian fault and South Anatolian fault, and Turkey entire country is basically moving along this fault zone. So when we have a relative motion along this fault zone, along this red line that I have drawn, we have observed the earthquake to happen that has happened few months back, when the most disastrous earthquake of more than 8.5 magnitude on the Richter scale that caused the loss of life, a huge loss of life. More than 50,000 to 60,000 people have died as a result of this earthquake in Turkey in recent times. So that is also, if examination question can be asked from current affairs. So questions like this can be asked, that recently we have observed a very severe earthquake in the Turkey region. What kind of plate interaction is responsible for such earthquake? And there can be three options: convergence, divergence, or CC convergence, CC divergence, OC convergence, O divergence, CC transform plate interaction. So what should be the correct answer? The correct answer is the Turkish earthquake has been caused due to continental transform plate interaction that is happening along North Anatolian fault and the South Anatolian fault. So that is how we can understand this. So these are all 6 types of plate interaction that we have discussed: 3 types of convergences, 2 types of divergences, and 1 type of transform plate interaction with 2 examples, best example which we can see on the earth. So that is all about the plate tectonics theory. I hope you understood about the basic concept of plate tectonic theory. Now coming to the question that which books to refer apart from NCERTs and GC Leong. So basically what I will suggest, that lot of questions are being asked from mapping. That means mapping is something which you cannot do in the last stage of the preparation. This is something you have to do together with your preparation. For example, if you are preparing for next 1 year, 1.5 year, 2 years. So keep on noting down all the places that is in news due to some significant events, whether it can be geographical event, whether it can be non-geographical event that is happening here. For example, outbreak of war, outbreak of famine, we have the large scale refugee movement, or any kind of environmental disaster that is happening. So refer to those places and keep on making notes of those places. Keep on looking and trying to find out, locate them on the atlas. So Oxford School Atlas will become very important source for the study of mapping or for preparation of the mapping based questions, what we can say. Apart from that, if you are done with NCERTs, class notes, what you can say, your GC Leong thoroughly, then after that you can refer to a book by Majid Hussain, Geography of India, especially for Indian geography, because nowadays they are going into more detail. The facts that are being asked from Indian geography, it is not available anymore in NCERTs. So either you have to look for internet by yourself, which is very difficult task. Then I would suggest you can refer to the Geography of India by Majid Hussain. Yeah, we have started this. This is our first lecture, so we'll keep on adding more and more topics in the geography, and we'll continue this series in further also, so that by the end of next year, when you are writing the examination, we can cover all the major topics that is required for the examination. Okay, so that is all for this particular session. Thank you very much.